we're now going to start graphing sine and cosine functions that are more than just sine x and cosine x. So I have written the general form that you will see, and there are 1, 2, 3, 4 different places where we could be adding numbers in that would change the graph. Okay. So what we're going to do is we're going to address each one in our set of directions here. Right? So A has everything to do with amplitude. So if A is 2, 3, 5, or 1/2, that changes the amplitude from 1 to whatever that value of A is. However, if A is negative, then there would also be a reflection, right? So a horizontal or reflection over the x-axis if A is negative. Okay. The other really simple one is the D. So let me come back to this page so I can look at this. This plus D right here, and for both of them, would be the vertical shift, up or down. And so we would identify just from looking at our equation, if there was a +4 or a -1, that would be how much the whole graph shifts. And the way I do vertical shifts is really straightforward. I basically just take this x-axis, let's say I was going to go up 1, and I just kind of put a dashed line here, and I treat that as my new x-axis. Okay. So it's a pretty easy translation to administer. Now, next to the C and the B will affect both the period and the horizontal shift. Horizontal shift is also often called a phase shift in trigonometry. So we have two kind of formulas here. The first one tells us that the period is going to be 2 pi divided by b. So let's go back, oopsies, and look at what the b is. The b is the number in front of the x. Okay. So the period for both sine and cosine will be 2 pi, which is its standard usual period, and then you will divide that by the number in front of the x. And so that will tell you how long it will take one cycle to occur. And then the other equation we have here is the phase shift or the horizontal shift. That will be negative c over b. And so running out of a little bit room here, horizontal shift, you don't get to just look at the plus c. Because there's this b here, it will be c over b. And the reason they add a negative is because you know how if it's a plus, it goes left, or if it's a minus, it goes right. So the reason there is a negative here is just to account for that. So if this was +3, and let's say this was 1, it would be 3 to the left. In other words, -3, right? So the negative is less, I'm less picky about whether you write it positive or negative. If you just write the direction, then that would work. Okay, so the first thing you're going to do is sort of identify all of those pieces. What's my period? What's my amplitude? What's my shifts, right? And then you want to mark the start of the period on the graph, the end of the period on the graph, and use the 4 other points of interest along the way to do the starts at 0, 0, goes up, goes down to 0, right? Those are the points you're going to use to draw the graph. So let me kind of give you a picture or an example of one of these. So we're going to graph this for at least one period. We're going to identify the amplitude, the shifts, and the period. Okay. So I'm going to start by looking at the A, the number in front, and that tells me that the amplitude of this graph is 2. So it's got to go up and down 2 from its x-axis. But does its x-axis shift? This right here tells me that the whole thing goes down 2. So if I'm going to start to draw I'm going to try to just put kind of an XY here somewhere. All right, so if these were my X and my Y, I'm gonna give myself a little tick mark here. Nope, I'm not gonna do that. 1, 2, 3, 4. Since the whole graph shifts down 2, this is basically going to be like my new x-axis. I'm gonna treat this as what was the x-axis in my original graph of sine. So when I say, oh, it starts at 0, 0, I'm going to treat this as 0, 0. And then it goes up, right? How far does it go up? Usually 1, but this time 2. So it'll go up, back to 0, 0, or back to the 0 or the midline, down 2 because of the amplitude, back to the midline. So I can already kind of see this shape forming. Okay. But then I have something here. I have a B. I don't have a C. I don't have a plus anything on the X, so there's no left-right shift, which is nice. But I do have to adjust my period. So my period is 2 pi divided by B. We know how to deal with complex fractions. So that's 2 pi times 4 over 3, or 8 pi over 3. So I don't have to shift it left or right, which means I'm going to start my graph at the 0 mark. But then when I end my graph, my last point, that will be at 8 pi over 3 instead of 2 pi. Okay. So I'm going to mark my points first. Remember I said for sine, it starts at 0, then it goes up next. So it would go up 2. Then it would go, and remember these are kind of like, I'm just going to go ahead and give myself these 4 equally spaced points, right? And this last one will be 8 pi over 3. So it's at the midpoint or 0, then it goes up. Then at the next one, it goes back to the 0, then it goes down, and then it goes back to the 0. And I'm going to try to connect those with a pretty, oh yes, slightly pretty curve, which I'm going to put arrows on the end to indicate that it keeps going. You're going to see this cycle just repeat. Now, it can't be that hard to do the math in between. Like this, if this is 0 and this is 8 pi over 3, the one in the middle is halfway. And then half of that. And then what's halfway between 4 pi over 3 and 8 pi over 3? So it's not too hard to, in general, sometimes it takes a little bit of fraction work to find the values of those x points. Okay, so that's an example of graphing a sine curve. Let's do a cosine curve. Okay, so same thing. We're going to start by picking out our amplitude, which in this case will be 3. This one is going to go up 1. So I can almost already start drawing my axes, but I'm just going to write down the rest of my information. What is my period? It's 2 pi divided by the coefficient of x, so 2 pi over 3. It's a shorter period this time. And then I do have a phase shift or a horizontal shift. So remember for that one, it's negative c divided by b. So negative pi over 3. Okay, so let me go ahead and try to draw a couple of axes in for myself. All right, it's going to go up 1. So this will be my new x-axis. I'm just going to go ahead and draw that in. And then an amplitude is 3. So I'm going to need to go up 3 and down. Well, 1 will be the 0, 2, 3. So when I go to draw my points, my top and my bottom will be here. Now, because I do have a phase shift, my first x point for cosine, I would usually start on top, right? Remember, cosine starts up at the top of its hill, but it's not going to be here at 0. It's going to be over here at negative pi over 3. So at this point, it probably makes sense for me to figure out what the value is of the last, what the rest of these x values are. So I know I need to put them on the correct side of the y-axis. Like if they're negative, they should be over here. If they're positive, they should be over here. So how do I do that? Well, if this is where I started, and this is my period, then when I add those two together, right, that's where it's going to end. Oh, okay. So if that's where it's going to end, I probably didn't put this in quite the right spot, because I'm going to need to start at negative pi over 3 and end at pi over 3, which makes the middle 0. And my other 2 points will be halfway in between, right? So I found the last point by adding the first plus the period equals the last point. And then the middle point, which is, I guess, kind of like x3, is just halfway in between the first and the last. So in this case, that would be 0. So that would make this, what, pi over 6 and negative pi over 6. Okay, so now I'm going to draw on my curve. I know that cosine starts at the top of its hill. So this is the new x-axis. It needs to go up 3. So my cosine is going to start up here. Then at the next x value, it hits the 0, which is the new x-axis dotted right there. At the next x point, it goes down to the bottom, back to the 0, and then it ends up at the top again. So this curve is looking something like this. Okay. All right, so that's graphing translations of sine and cosine.